Page 25. Number 125. Go ahead and read it and then come back. Okay, if you don't know what a BTU is, you're not alone. Most people don't. And I'm going to show you how to do this problem without knowing what a BTU is. Okay, let's go to the ask of the question. They're saying how many BTUs per cubic foot were produced in the elevator. BTUs per cubic foot. It's telling you you're going to divide the number of BTUs by cubic feet. Now then, I want you to think about, well, what the heck is cubic feet? Cubic feet is feet cubed, which is a measurement of volume. So they're basically telling you, take the number of BTUs, divide it by the volume of the elevator. So let's get set up here so that we know what we're doing. We're doing BTUs, whatever it is, and I don't even know what a BTU is, talk about the end, divided by the volume of the elevator. All right, let's go through the problem. A 12-person basketball team, so we have 12 people coming into the elevator. The elevator is 10 feet by 12 feet by 9 feet. Okay, so let's assume that if it's an elevator, it's probably going to be a box shape, a rectangular prism. So I'm going to go ahead and give you a master class in art and draw this amazing looking elevator. So the one rectangle, so the second overlapping rectangle, and then we're going to connect the corresponding vertices. Okay, so here's my elevator, my rectangular prism. It's 10 feet by 12 feet by 9 feet. I'm going to throw this in as length, width, and height. Each player emits 900 BTUs. So there's 12 people, but each person lets out 900 BTUs. Okay, so for the number of BTUs that were emitted in this elevator, it's going to be 12 times one person's BTUs. So 12 times 900. All over the volume of this shape. Now, since it's a box-like figure, the quick and dirty way of finding anything that looks like a box, the volume of a box would be length times width times height. So in this case, it's going to be 10 times 12 times 9. Let's go ahead and do that in the calculator. 10 times 12 times 9. So 1,080 cubed feet. I was about to say square feet. 1,080 feet cubed. Okay, so that's my volume. So I'm going to plug that in. 1,080 feet cubed. Okay, so let's go ahead and simplify this further. So 12 times 900 in the calculator to figure out the total BTUs that were emitted. So that's 10,800 BTUs over, I'm going to put BTUs, over 1,080 feet cubed. Let's divide. So 10,800 divided by 1,080 equals 10. 10 BTUs per cubic foot. My answer here is going to be 10. I didn't have to know what a BTU is. There were enough clues in the question to let me figure it out. Anytime you see the word per, you're going to think you're dividing whatever is before it with whatever's after. And whenever you see something cubed, you're thinking volume. Now let me tell you what a BTU is. BTU stands for British Thermal Unit. Kind of like Fahrenheit or Celsius. British Thermal Unit, BTU. But we don't care about that because at the end of the day, we figured out an answer anyway. All right, let's keep moving. Number 126. Read it and then come back. Okay, so we are looking to complete the algebraic descriptions so the rules, for the transformations that map circle A onto circle B. Now, we've talked before how all circles are similar, and there's two things that need to happen to map one circle onto another. The first one is a translation, so that the centers map on top of each other. And then the second thing is a dilation. You want to dilate with a scale factor equal to the new radius, new r, new radius, over the old radius. So we've gone over that before. Now let's take a look at what they want us to do. Notice the first thing that they're doing is saying xy becomes blank, and then xy becomes x plus something and y plus something. Now, the way that they're doing it, they want the translation to come second. Usually I want the translation to come first so that the centers map on top of each other. But here they want the translation to come second. They want you to dilate first. That's going to be a little tricky at one point. And the reason it's going to become tricky is because the location of A will change after your dilation. But okay, let's start talking about our dilation first. Our rule for dilating should look like x comma y becomes k times x, k times y. All I need to know is k. Now to figure out k, which is your scale factor, we're going to do our new radius over our old radius. Remember, circle A maps onto circle B. So circle B is your new circle. So circle B, let's go ahead and draw in the radius, nice and simple. The length for the radius is 3. The length for radius A is 1. So new over old is going to be a length of 3 over a length of 1. Our scale factor, our k value, is just 3. So your circle needs to become 3 times as big in order to be the same size as circle B. Let's go ahead and fill in our rule. X comma y becomes 3 times the x coordinate, 3 times the y coordinate, and then the two circles will be the same size. The next thing I need to do is translate so the circles map on top of each other. The issue is, since I have now dilated my coordinates, point A won't be at -4, 1 anymore. Let's take a look at where it's going to end up. So point A, which is at -4, 1, is going to dilate by a scale factor of 3. So that means the x and y should get multiplied by 3. And now A prime is going to be at -4 times 3, which is -12. 1 times 3, which is 3. So A prime is going to be at -12, 3. Definitely off my graph. Could I grab another piece of graph paper and make my graph bigger? Absolutely. But I'm just going to sketch it. -12, 3 is going to be like right around here. So I'm going to label this A prime. Now my circle will be the right size, but it's just not going to be on top of circle B. Now to get it on top, I need to move it over and I need to move it down so that it maps onto the center of circle B. Now let's take a look at the coordinates so I can figure out what these movements need to be. A prime is at -12, 3 because it moved after the dilation. And then B is at 2, 2. So let's think. How are we going to get from -12 to 2? We're definitely going to add. We're going to add 14 to get from -12 to 2. And now to get from 3 to 2, we're going to subtract. We're going to subtract 1. So those are going to be our movements. Right 14, down 1. So plus 14 and minus 1. I'm going to go ahead and I'm going to fill that in as my final answer for the translation. So plus 14 and then a minus 1. Okay, and I'm done. So remember, any circle can turn into any other circle because all circles are similar. You just have to do a translation and a dilation. Translate first, if you can, if you have the option. Translate first so that the two centers map on top of each other. And then dilate by a scale factor of new radius over old radius. It's just that in this scenario, they did not translate first like I'm telling you to do. They dilated they dilated first, which means that your center point A moved before you could get it to map onto circle B. Okay, let's move on. 127. Read it and come back. Okay, so we're trying to figure out what metal is the ring made from. Now, they're giving us a table of different metals and they're telling us their densities. So you're thinking density is going to tell you which of these metals is the correct metal. Now, when we talk about density, you need to think about the density triangle. The density triangle looks like this. D, M, V. Kind of like Department of Motor Vehicles, DMV. D stands for density, M stands for mass, V stands for volume. Let's take a look at what they gave us about our wedding ring band that will help me figure out the density. Okay, so they said the wedding ring band weighs 112 grams. Okay, so that is your mass, 112. I'm going to go ahead and write that down. Mass equals 112 grams. They also told me that my wedding ring band has a volume of 10.76 cubic centimeters. Okay, so they gave me volume. Let me write that down as well. V equals 10.76 centimeters cubed. Now I need to figure out the density so that I can figure out, well, which metal is it? Now our density triangle says if you're trying to solve for density, look at where M and V are. M is on top, V is on the bottom. It's telling you divide. Do mass divided by volume. So to get density, you're going to do mass divided by volume. So you're going to do 112 divided by 10.76. Let's go to our calculator. 112 divided by 10.76. 10.408. Okay, so it's approximately, for your density, it's approximately 10.41 grams per centimeter cubed. All right, looking through our choices, the closest one is going to be silver. All the others are too far away. So our closest choice is silver. Looks like our wedding band is going to be made up of silver. So remember your density triangle. It's going to tell you how to solve for whatever's missing, whether it's the mass that's missing, the volume, or the density. As a quick recap, if I was looking for mass, since density and volume are next to each other, if I have the density and I have the volume, I'd multiply them together. Okay, this means multiply because they're next to each other, and that would get you the mass. All right, let's move on. Number 128. Read it and then come back. Okay, so the ask of this question is to find the volume of the composite figure to the nearest tenth. Now, a composite figure is one that's made up of more than one shape. So here we see that there's a pyramid and there's a sphere. So if we want to find the total volume here, we're going to have to find the volume of the pyramid and the volume of the sphere and then add them together. Okay, let's start with the volume of the pyramid. Let's take a look at what they gave us. So they said that this pentagonal pyramid has a base area of 125 square inches. Okay, so area of the base equals 125 inches squared. Okay, and then the height of the pyramid equals 20 inches. So they're both in the same unit of measurement, inches. And then they tell us that the sphere has a radius of 4 inches. Okay, so the radius here is 4 inches. Good thing again, they're all in the same unit of measurement, inches. Starting with my pyramid, I need to think about what is the volume formula for a pyramid. Well, anything with a point at the top is going to be V equals 1/3 big BH. And we've done a couple of these already. So I'm looking at this formula and I'm thinking, okay, well, what's the height? I like to plug in height first. They gave me the height. Straightforward. It's 20 inches. So I'm going to say V equals 1/3. Plug in 20 for my height. Now, big B, remember, stands for area of your base. In this case, our base is a pentagon. Now, I could potentially have to do a lot of work to figure out the area of that pentagon, but luckily in this problem, they just told me. They said your area for your base is 125. So very straightforward. They gave me big B. They gave me the area. It's 125. That saved me a lot of work. All right, so I'm just going to multiply these things together, and I'm going to get the volume of my pyramid. So V equals, I start with the big B, 125, times 20 equals, divided by 3 equals. All right, so 833.3 repeating. So 833 and 1/3. That's 0.3 repeating. Inches cubed. Okay, let me do the sphere now. So volume formula for a sphere is 4/3 pi r cubed. All you have to know is the radius of the sphere. And we do. It's 4. So we're going to plug in. And now we have V equals 4/3 pi 4 cubed. Now the way that we're going to multiply this is we start with the 4 to the 3rd power first. Then after we get that, we're going to multiply by 4 and then divide by 3 and then finally multiply in pi. That's the way I like to do it. If you want to do it a different way, go right ahead. So 4 to the 3rd power is 64 times 4 divided by 3 equals. So it's also 85 and 1/3 pi. Let me multiply the pi in. Times pi equals. Okay, so the volume of the sphere is approximately 268.0825. Oh, will be 826 if I go out 4 decimal places. Okay, we have to round to the nearest tenth. So I'm going to keep this in my calculator. I'm going to press plus 833.33333333333. I could get 1/3 in the calculator. I'm just not going to. I think this is going to be sufficient. Equals. Okay, so that's going to be my final answer after I've added together the two volumes that I found separately. So my final answer after I've added is 1,101 point, so to the nearest tenth, 0.4 inches cubed. So that's the volume of the composite figure shown. Okay, let's move on. Number 129 is a visualization question. I've gone ahead and I've drawn a cube. It says, what cross sections can a cube have? Okay, let's go through the list. So cross sections are when you take a plane and you just slice it. In whatever direction you slice it and you take a look at what shape resulted. The first one said a square. Absolutely, you're going to check that off. You are definitely going to get a square. A cube has all the sides as squares. And if I took a plane and I just went parallel to my base, it would create a square. Next one, a rectangle. Yes, it can form a rectangle. If I drew my plane kind of intersecting like this, right, and you visualize what it would look like when it cut like that, cut at its diagonal, it's going to be a rectangle. So yes to the rectangle. Okay, next one, a parallelogram. No, a parallelogram will not be formed because there's all straight edges here. So no, no parallelogram. Next one, nope, no circles are going to be formed with a cube. Next one, an oval. Nope, nothing circular. And lastly, a triangle. The answer is yes. If I took my plane and I kind of cut off just a little corner here. You're going to form a little triangle when you take a look at it. Yes, you will get a triangle. So 3 choices: square, rectangle, and triangle. Let's keep going. 130. What cross sections can a cylinder have? Okay, so I drew my cylinder. First one is a square. Now that is possible. A square is possible. I want you to imagine that if you were to cut your cylinder down the center and you took a look at what was formed, what you would really see is a rectangle. So I'm definitely going to get a rectangle. But if the height of the cylinder was the same as the width of the cylinder, it would form a square. So a square and a rectangle are possible. I'm going to go ahead and check off the rectangle as well. A parallelogram. Unless your cylinder is slanted, unless it's oblique, it's not going to form a parallelogram. So I'm not going to check off parallelogram. The next one, a circle. Absolutely, you're definitely going to get a circle. The top and bottom are circles. So if you go parallel to your base, you're going to see a circle when you open it up. The next one said an oval. Okay, now let me get rid of these 2 markings. Put my circle check back. Okay, if I do an oval, if I kind of just slant my plane, you are going to see an oval pop up here. So the answer is yes, you will get an oval. And last one, a triangle. The answer is no, you're not going to get a triangle. You're going to get something that may look like this, but not a triangle. So our only 4 choices are square, rectangle, circle, and oval. And we are done with this page. Let's keep moving.